of our variables. All of these are rates, so it's d something dt when we're talking about the derivatives. And we also need to kind of figure out what formula might be most useful in each of our problems. So this one we have a funnel in the shape of an inverted cone. What does that mean? Did I do this one already?
We did something similar.
We did a similar one. Okay. I was gonna say, this seems very familiar. So we have a funnel in the shape of an inverted cone. So that's just like your upside down cone. It is 30 centimeters deep. So what's that? The height of this whole cone. And the diameter across the top is 20. Okay, we never really use the diameter for anything. We always use the radius. So if the diameter is 20, what would our radius be? Quick check, make sure your units match. These are all centimeters, so we're okay. Liquid is being poured in at a constant rate. So we've got water coming in. I don't know what that rate is. And it's flowing out of the funnel. So now it's coming out at a rate of 12 cubic centimeters per second. What would this be? Right, it's the derivative of volume, dV dt. Now, we have to be a little bit careful. dV dt is not just 12. Because there's two things happening. We have water coming in and water coming out. Do we know how fast the water's coming in? No, we just know it's a constant rate. So I'm just going to call it C. Whatever it is, it's not changing. I turned on my sink full blast and I'm just letting it run. And then it's coming out the bottom at a rate of 12. So your volume, what would you have to do with these things? Subtract them. The rate it's coming in minus how fast it's coming out. Just like if you're going to wash dishes, you turn on the sink, but you don't have the drain plug in all the way. So water's coming in, but it's also leaking out at the same time. All right, the height is rising at a rate of 20.25 centimeters per second. So what would that be? Make sure all of these units are centimeters, so we're okay. If something were different, we'd have to convert them so they all match. At the instant when the liquid in the funnel is 20 centimeters deep, what is that? H. All right. Let's talk about formula here. We have volume of a cone. I think you guys should have a blank slide after this if you need it. So volume of a cone is 1/3 pi r squared h. If I do this derivative right now, I will have a dv dt, a dr dt, and a dh dt. Is that okay? What's wrong with that? There's a lot of them. I have numbers to plug in for dv dt and dh dt, but I have nothing with an r. So it would be useful to get rid of that r before we do the derivative. All right, so let's go back to this one. Okay, we could think of this as a triangle. The height is 30, base is 10. Okay, so at any point, we could use similar triangles, right? So we know that 10 over 30 is always equal to r over h. So if you were trying to solve for r, get r by itself, what would you do? Multiply your h over, so that would give us h over 3 is equal to the r. Okay, so now I know the radius is always just a third of the height. So I'm going to replace this r and simplify as much as I can before I do my derivative. So 1/3 pi, I'm just going to write that as pi over 3. My radius is always the h over 3 squared times h. Okay, so this would be h squared over 9. So pi over 3 times h squared over 9. So it would be pi over 27h to the third. Take a second. Have I lost anyone there? We have a lot going on. So I did pi over 3 times h squared over 9 times h. So I took pi over 3, multiplied the 9 with that, and then I did the h squared and the h together. Any questions? Okay. So now we can do our derivative. Because we have v and h, we have the dv dh, or dv dt and the dh dt, so it's okay to do our derivative. So derivative of v would become this one, going down by 3, so that would make it pi over 9 h squared times the derivative of h is dh dt. So plug in what we know. dv dt is c minus 12 equals pi over 9 times 20 squared times 0.25. Pi over 27 times 3. We'll do our derivative. Exponent comes down. So 3 over 27 is 1 over 9. So definitely not pretty, but we get this constant rate, 46.9066, or you could have left it in terms of pi. This is how fast the water is coming in, so it is a volume, so it'd be cubic centimeters per second. So that is how fast the water is coming into the cup. Questions on that one? Let's take a look at this one. A man, 6 feet tall, walks with a speed of 8 feet per second away from a street light that is atop an 18-foot pole. How fast is the tip of his shadow moving along the ground when he is 100 feet from the light pole? What kind of picture would I draw here? So here's the light pole. We know it's 18 feet tall. Quick check, everything units match, so we're okay. If something were inches and something were feet, we'd have to make them match. Our man okay, he is 6 feet tall. Okay, and I know how fast he's walking. I'm trying to find how fast the shadow is moving. So where is his shadow going to be? Let me ask that question first. Where's your shadow again? On the ground, and would it be behind him or in front of him? In front of him, because the light is behind him. So here's his shadow. If I want to know how fast that's moving, that has to be a variable. We also know how fast he is walking. So from here to here has to be a variable. So we have a couple things here. So we could say maybe how far he's walked could be x. And then to get all the way out here, we'll have to have a second variable. So we'll call that one y. So what we really have here, I can't draw straight lines. Similar triangle. So we have one triangle where the height is 18 and the bottom is y. The second triangle, the height is 6. The bottom is this piece. What would I call that? The whole thing is y, and from here to here is x. Mm-hmm. Let's write down the other information given. We know his speed, so dx dt is 8. And we want, let's see, how fast the tip of the shadow is moving, so we are looking for dy dt. When he is 100 feet from the pole, so at the point when his distance is 100. All right, we need some kind of equation. We have the x dt, we're looking for dy dt, so we need both variables in it. What kind of equation could I use here? Pythagorean theorem is a common one, but I don't have any mention of this side. So I would have to make it another variable, and do I have any rates for that variable? No, so that probably wouldn't be ideal. Think about this. We have similar triangles. What do we do with those? Okay, we set those proportions equal, don't we? So we could say 18 over y is equal to 6 over y minus x. Alright, this would probably not be my favorite thing to do the derivative of because we have quotient rule. Is there a way I can make it nicer? You could. What else could we do? We could cross multiply and get rid of all the division first if we'd like. So if I do that, if you really wanted to make life easy, couldn't we combine like terms? So I could subtract over my 6y. Okay, that's not bad. We could do this derivative. What would be the derivative of 12y? minus the derivative of 18x. Equals 0. I don't know my dy dt. Dx dt is 8. What would my units be? Questions? I think we have one example left. Why don't you guys read it and see if you can at least draw a picture? So we know we have a right triangle, so that's our picture. Okay, and it tells us the height is 1/3 the length of the base. So options, we don't really know yet. You know, this is the height, this is the base. If the height is 1/3 the length of the base, we could call it like 1/3 times the base. But let's see if that's what we need to do. Okay, so before you change anything, let's read the rest of the problem. How fast is the area changing? So what are you looking for? We need dA dt. When the height is 5 and increasing 2 centimeters per second. So this is how the height is changing. So that's dH dt. Okay. What's the area of a triangle? Alright, so we know we probably would like to get rid of one of those variables first. We need dA dt. I have information about h. Did I give you anything about d? So the base is actually the one I want to replace. So go back to this. I don't want it to be in terms of the base. If the height is 1/3 the base, your height is 1/3 the base. So if you multiply the 3, your base is 3 times the height. Okay, and I'm doing that because I didn't give dB dt, so the b has to go away. I want to keep the h. Does that make sense to everyone? So we'll plug that in before doing the derivative. So instead of base, we're going to call that 3 times the height. So my area is 3/2 h squared. So now we can do the derivative. Derivative of a would be dA dt. Exponent comes down, so 3/2 times 2 is 3h. Subtract 1 from the power, and then times dH dt. What would my units be? Area is square centimeters per time within. Questions? So we had on this homework, we had changed. I changed the homework last Thursday. I think I took off 13 and I gave you 31 instead. So we're going to do the 13 and with today's problems. Tomorrow we are going to do a work day as well. So there's double the problems today, but you will have class time tomorrow as well to work on all this. And then it will be due on Monday, the entire section. And especially because we've had so many breaks in this section, I feel like it's really hard to learn something when we do a little bit and have a few days off and do a little bit more. I will probably on Monday take another day and just kind of practice this